What if AI could learn to see the world more like we do? Not by memorizing every single detail, but by actually understanding the meaning behind what it sees. Well, today, we're going to dive into a brand new architecture from Meta that's doing just that. It's called VL-JEPA, and it's a huge step forward because it's all about learning smarter, not harder. So let's just get right to the heart of the problem. Our most powerful AI models, the ones that do all these amazing things, they are incredibly wasteful. I mean, they consume just massive amounts of data and energy to learn even pretty simple concepts. For real-world use, that's just not sustainable. Okay, here's a great way to think about it. The old way of teaching AI is like a perfectionist scribe. It has to painstakingly model and generate every single word, every little detail. It's slow, it's expensive, and honestly, it kind of misses the point. The new approach, the VL-JEPA way, is more like a brilliant summarizer. It just looks at the information and instantly gets the core idea, the meaning. It's just a much, much more efficient way to learn. And this is a really big deal. This obsession with getting every single word exactly right means these traditional models get bogged down. It makes them super expensive to train and really slow to run. That's why they aren't always great for real-time applications, where you need an answer right now. So what's the big solution here? Well, what if we could get an AI to skip all those tiny linguistic details and just predict the underlying meaning? That is the whole idea behind this new model from Meta, FAIR, called VL-JPA. It's a total shift in strategy. The secret weapon here is something called an embedding. Now, instead of thinking in words, VL-JPA thinks in these abstract numerical representations. You can kind of picture it like a big map of ideas, a semantic space. In this space, similar concepts like dog and puppy are really close together, while something like cars way off in a different neighborhood. This is how the AI starts to understand relationships, not just words. And here's where that gets really powerful. A traditional model would have to learn two totally separate things, the phrase, the lamp is turned off, and the phrase, the room will go dark. But VL-JEPA is smarter. It learns a single shared concept of the light going out. That simplifies the whole process and makes learning way more effective. Okay, so how does this thing actually work? How does it build this amazing map of meaning? Let's pop the hood for a second and take a quick look inside the architecture. All right, I know this diagram looks a little intimidating, but the core idea is actually pretty straightforward. You've got your inputs on one side, the text and the images, and what the model learns to do is predict the embedding, the abstract meaning of what's coming next, not the exact words. That's the key difference. You can think of it like this. The X encoder sees the world and turns it into a compact idea. The Y encoder knows what the target idea or meaning is supposed to be. And then the predictor's job is to look at what the X encoder saw and guess what the Y encoder is thinking. It constantly tries to connect the visual input to the abstract meaning, and over time, it gets incredibly good at it. Now, this all sounds fantastic in theory, right? But does it actually perform better? Well, the researchers put it to the test in a really strict, controlled head-to-head competition. So they set up a really fair fight. They took VL-JEPA and put it up against a standard VLM that predicts words. And to make sure it was a level playing field, they gave both models the exact same vision encoder, the same training data, and the same amount of time to learn. The only thing that was different was the goal: predict meaning versus predict words. And wow, the results are pretty dramatic. You can see it right here. VL-JEPA, that's the blue line, consistently outperforms the traditional model in red. And it's not just that it ends up higher, look at how much faster it learns. That steep curve shows it's just way more efficient at getting to a better result. And get this is the real kicker. It achieved these better results with about half the number of trainable parameters. We're talking half the size. It's proof that a smarter strategy can easily beat raw, brute force computation. And you don't have to take my word for it. The researchers themselves concluded that this experiment clearly shows the benefit of predicting meaning. It leads to higher efficiency and just plain stronger performance. It's a win-win. Okay, so it's more efficient, it's a stronger performer, but why does this actually matter for, the real world? Well, because this leap in efficiency unlocks all sorts of new possibilities for AI that can work in real time. And it has a secret weapon to make this happen, something called selective decoding. See, because it's not generating text word by word, it can create this continuous stream of meaning. It's constantly understanding what's going on, but it only translates that understanding into text when something important actually changes. This is absolutely perfect for things like smart glasses or robotics. Think about it. The AI needs to be aware of its surroundings all the time, but it only needs to act or report back when something actually happens. This saves a massive amount of computational power. And the data proves just how well this works. Just look at this graph. Selective decoding can get you the same level of performance with way fewer resource-intensive operations than constant decoding. It's working smarter, not harder. We are talking about a nearly 3 times reduction in the cost of decoding, all while maintaining the same quality. For real-world use cases, that is a gigantic leap in efficiency. And this efficiency doesn't mean it's limited in what it can do. Not at all. This one unified architecture can handle a whole range of different tasks, from classification to question answering, and it often outperforms established models that were built specifically for those tasks. In fact, and this is maybe the most impressive part, on a really tough benchmark designed to test an AI's understanding of cause and effect, VL-JEPA set a new state-of-the-art. It even beat some of the biggest models out there, including GPT-4o. This shows it's developing a more sophisticated, grounded understanding of how the world actually works. So is this it? Is this the beginning of AI that can truly see, understand, and act in our world right alongside us in real time? By learning to focus on what really matters, the meaning, VL-JEPA is paving the way for a whole new generation of AI that's more responsive, more efficient, and just more capable. The age of the perfectionist scribe might just be over.